Hey yo, what's up? Welcome back. Now we're going to learn about a concept that's known as inertia. So, inertia should be in your science. You need to add this to your science notebook. You need to include the definition. You need to also then include how mass affects inertia as well as how acceleration affects inertia. And in each of those, you need to include some pictures or some free body diagrams to enhance those effects. So let's get into it. Inertia. It's the resistance to change an object's motion. Okay, so it's a concept. The word's kind of weird. It's a challenging spelling. Inertia. Make sure you get that spelled correctly. But it's something you actually have encountered many times in your life, and you know this concept. We just have to put this word to this concept that you've seen in your life. So let's think about this. We have two different kettlebells here. One is 5 pounds. So if this kettlebell is here, we have a 5-pound force in the downward direction. In order to lift it, we have to lift greater than 5 pounds. So let's say we lift this with 10 pounds of force. We have to use that 10 pounds to pick up the 5-pound kettlebell. So when we do, you can see 10 pounds of force would pick that kettlebell up really quick. Well, if we have this 50-pound kettlebell, and we try to apply 10 pounds of force to this one, we're not going to be able to pick it up because we didn't overcome the downward force. So the reason that this one, we didn't pick up the second kettlebell here, a lot of times we say it's too heavy, but really we just were not able to overcome the inertia of the object. It has a big resistance to change its motion. It doesn't want to change its motion because it's what we would call heavy. This one that's lighter, or we'd say is lighter, it actually has less inertia, has less of a resistance to change its motion. So let's take a look down here at a baseball and a bowling ball. So if we think about a baseball has more mass than a bowling ball. So if both of these objects were moving at 60 miles an hour forward, let's say 60 miles per hour, a force was applied to them in the forward direction, or it's really their speed. The force was applied in newtons because newtons is the measurement of force. But when we measure the speed of the object, we can use miles per hour. Now, you can imagine that the force would be different of a baseball traveling at 60 miles an hour compared to a bowling ball traveling at 60 miles per hour. The one that has more mass, the bowling ball, is going to end up applying more force than a baseball. So if you were trying to knock down a bunch of bowling pins, you can see why we don't use baseballs in order to knock down the bowling pins, because you'd have to throw that baseball much harder than you would a bowling ball in order to knock those pins down. But since a bowling ball has more mass, it has more inertia, which means it has more force that it can be applied to these bowling pins to knock those over and get a strike. So what that means then is an object with more mass has more inertia if both objects have the same speed. So here the bowling ball has more inertia because it weighs more, but it's going the same speed as the baseball, so that's why it has more inertia. For the kettlebells, these are going the same speed. Neither of them are moving, so their speed is 0, so the one with more mass has more inertia. Now let's consider if we have something that is the exact same mass. So we have two bowling balls here, and let's say that this one is not moving very fast, whereas the second bowling ball is moving much faster. So if we're trying to get that strike and trying to knock down the bowling pins, you can just imagine which one is going to do a better job of knocking down the bowling pins. So the one with less speed, it's going to be easier to change its motion. It's going to be easier to stop it. So therefore, it's going to have less inertia, because inertia is the resistance to change its motion. So if it's got less resistance to change its motion, that means it's easier to change its motion, so it has less inertia. If we have more speed or acceleration, that means it's going to have a lot more of a resistance to change. It's going to be hard to change, so it's going to have more inertia. Now, they actually say that the people on the Titanic knew that there was an iceberg that was up in front of the Titanic, and they told the captain to steer the ship away. But the ship had a lot of mass and a lot of acceleration, so therefore it had tons and tons of inertia. So it was moving towards that iceberg, and they tried to change it, but it had too much inertia. They couldn't actually change the boat fast enough. So it's kind of like, it's easy to have a little toy boat change its direction in a lake because it doesn't weigh very much. But you have a huge boat in a lake and it's moving in a certain direction, it's hard to change its motion. It's hard to steer it off course because of all of its momentum. So again, if we have a 40 mile an hour baseball, a 75 mile an hour baseball, and a 98 mile per hour baseball, if you're a batter, if you need to change its motion so that you can hit it into the outfield and try to get a home run, the 40 mile an hour baseball is going to have a certain force that it's going to apply to your bat. The 75 mile an hour baseball is going to have a certain force, and the 98 mile an hour baseball is going to have even more force. So they're all the same mass, but they're traveling at different speeds. So what we would say is the one that's moving slower has less inertia compared to the one that's traveling faster has more inertia. The more inertia it has, the harder it is to change its direction. That's why pitchers try to throw really, really, really hard, not only to get the reaction speed, to mess with the reaction speed of the batter, but also because it's harder to hit a home run if the ball is moving at a faster speed. An object's inertia increases as the acceleration, there's that word I was looking for. An object's inertia increases as the acceleration of the object increases. An object's inertia increases as the acceleration of the object increases. So again, don't forget to include the definition for inertia, the effects of mass, and the effects of acceleration. Also include some visuals to help you out in your science notebook. All right, see ya.